Hey everyone, and welcome to today's Explainer. We're doing things a little differently this time around. I want you to literally step into the shoes of the senior network expert. Imagine you're sitting at mission control, and today you're about to guide a field engineer through a complete, ground-up Aruba Wireless deployment. We're going to take all the raw source material on Aruba L2 networks and turn it into your ultimate step-by-step playbook. So picture this. Your field engineer is standing on site right now, a brand new access point in hand, just waiting for your go-ahead. But hold on, before we tell them to plug absolutely anything into the wall, we really need to understand the environment we're deploying into, right? I mean, flying blind and networking, that's just a one-way ticket to a help desk nightmare. Let's get our bearings first.
Okay, let's take a quick look at the agenda. We're going to hit the core infrastructure, understand the APs themselves, walk through the actual field deployment, tackle any instant-to-campus AP conversions, and then wrap it all up with some troubleshooting.
All right, Section 1, Core Network Infrastructure. You literally can't troubleshoot an access point if you don't know what back-end systems it's talking to, so let's lay down that foundation. First up on our back-end tour is the Mobility Master. Think of this as the next-generation brain of your entire operation. It runs Aruba OS 8.x, usually as a VM or a hardened appliance, and it's what allows for those really nice, seamless software updates. But here's a crucial thing to remember if things ever go sideways. If the Mobility Master completely goes down, don't panic. Your local mobility controllers and your APs actually stay up. They'll keep right on broadcasting those SSIDs, you'll just temporarily lose some of the higher-level stuff, like AirMatch or remote AP onboarding. Next up, we have Aruba ClearPass. Basically, ClearPass is the highly intelligent bouncer of your network. It's an advanced policy management platform that handles onboarding devices, granting specific access levels, and just keeping the whole network secure. Whether it's a corporate laptop or someone's personal phone, ClearPass safely handles it strictly according to the rules you've set.
Then there's Airwave. So when your field engineer asks, hey, how's the network actually doing? This is where you look. Airwave is your go-to diagnostic platform. It gives you these incredibly detailed health and analytics dashboards, making it super easy to view client usage, monitor configuration compliance, and keep a close eye on alert summaries. And to keep all of this running optimally, we lean heavily on band steering. You see, we have way more channels available on the 5 GHz band than on the super crowded 2.4 GHz band. By actively encouraging dual-band capable devices to move over to 5 GHz, we significantly reduce co-channel interference. And the best part, it frees up that precious 2.4 GHz space for single-band clients that really need it, like older VoIP phones.
Moving on to Section 2, Understanding Access Points. We know the back end, so let's talk about the actual piece of hardware your engineer is holding right now.
So there are two main deployment modes you've got to understand here. On one side, we have the Campus AP, or CAP, which requires a mobility controller and runs an Aruba OS image. On the flip side, we have the Instant AP, or IAP, which is built for controllerless setups and runs its own instant image. Now, keep in mind, a lot of models, like the 303H or the 365, are actually universal. That means they can operate in either environment, and it all depends on what they discover when they first boot up.
Which brings us to a great question. How exactly does an AP know which mode to use? Well, it follows a very strict discovery process right at boot time. First, it tries to resolve a DNS name. If it strikes out there, it looks for DHCP option 43. If that's not set up, it broadcasts out using the Aruba Discovery Protocol, or ADP. And if all else fails, it simply looks for the default hostname, Aruba Master. It goes down this list in exact order until it successfully hits a managed device.
All right, Section 3, the field deployment. The theory is officially out of the way. Your field engineer is standing at the wiring closet, AP in hand. Let's get this thing online.
Okay, here's where you guide them step by step. First, tell them to connect the AP directly into a switch access port. Once it's physically plugged in, you jump onto the switch CLI and run show LLDP neighbor. That's going to give you the IP address the AP just pulled from DHCP. Next, have your engineer connect their laptop to a spare port on that exact same switch, make sure they pull a DHCP address in the same range, and then just punch the AP's IP into their web browser. Oh, and the default login to get into the GUI, it's just admin. Which brings us to Section 4, converting IAP to CAP. Great, the AP is online. But wait, what if it booted up using its factory image as an instant AP, and your network architecture specifically needs it to be a campus AP tied to a mobility controller? Well, we got to convert it.
Let's walk through the UI together. Tell your engineer to look at the main instant dashboard.
Right up there in the top right corner, have them click on the link that says Maintenance.
Once that new window pops open, you'll see a row of tabs right across the top. Have them click directly on the one labeled Convert. Now pay close attention here because precision is absolutely key. There's a drop-down menu with a few different options, and you need to make absolutely sure they select the one that explicitly says Campus APs managed by a mobility controller.
Lastly, right below that drop-down, have them type in the host name, the fully qualified domain name, or the IP address of your mobility controller. Once that's in, just hit Convert Now. The AP is going to reboot on its own, dump its instant image, and come back to life operating as a full Campus AP entirely managed by your controller.
And finally, Section 5, Troubleshooting Wireless Issues. The install is done, the AP is converted, but hey, you and I both know the job isn't over just because the lights are flashing green. Let's dig into some post-deployment troubleshooting.
So imagine you log into the Mobility Master's command line just to double-check the configuration. And boom, you see these weird symbols, like a caret or an asterisk, just sitting there at the end of your prompt. What do they actually mean? And more importantly, how do you clear them?
It's actually super simple once you know the secret code. A caret symbol just means you have a pending, uncommitted configuration sitting on one of your nodes. To fix it, just issue a write memory command to save things. An asterisk, on the other hand, means there's a crash dump file sitting on the controller. You can extract that file for support if you need to, and when you're done, just run tar clean crash to wipe it and clear that asterisk from your prompt.
Now, what if the AP is totally up and running, but a user submits a ticket saying they can't connect to the corporate Wi-Fi? Well, after verifying the SSID is actually broadcasting, you need to dig deeper. Navigate over to Dashboard, then Overview, and click on Clients. This specific page is an absolute goldmine. It gives you a full summary of active clients, their health scores, their IP addresses, including if someone's stuck with the dreaded AP-IP address, and their signal-to-noise ratio.
And here's a massive pro tip for you. If clients are failing to authenticate and you spot an invalid calling station error in your network policy server event log, there is an exact known fix for this. You have to go in and increase the 802.1x client timer to exactly 60 seconds. Also, as a general best practice, make sure your APs are authenticating directly to the MPS instead of routing that traffic through the controller.
One last scenario. What if clients connect fine but keep dropping when they walk between buildings? Run through this checklist. First, check the AP power status. Next, evaluate the physical roaming distance and the overall AP density in that spot. Make absolutely sure fast roaming is actually enabled. And finally, check ClearPass or ISE to see if there's a stuck ghost session for that SSID that's preventing a clean roam.
And with that, your field engineer has successfully deployed, converted, and verified the hardware. Awesome job. But I want to leave you with a final thought. Getting an AP online, that's really just day one. The true mark of a networking expert is asking yourself, is this environment truly optimized for the absolute best client experience? Keep monitoring